So this presentation is split in two parts. The first part is proper microscope usage and mosquito manipulation. The next part is going to be on a dichotomous key and how to use a dichotomous key. I would suggest with this part you sit at your desk with your microscope in front of you, and I'm going to teach you how to adjust your microscope so that you're properly using it. And then next, with the dichotomous key, I highly suggest talking with your biologist and having a mosquito sample in front of you, preferably the one that I'm using, and then we'll go through the key in step by step in how to ID it. So most of us are using dissecting scopes, dissecting microscopes similar to this. We've got, the platform here where you put your sample in a petri dish and the light is shining through. You can have light sources that are like this, where they're these like wands that you can point at your subject. Or you can have a light ring that kind of goes around this portion of the objective lens of your microscope and kind of shines on the samples. There are lots of different types of microscopes and things like this, but this is just a common kind of generic. When shining your light, so if you do have these wands, you're going to play with the light and you're going to kind of make sure that the subject is being lit up as much as possible with the light that you're using. You want to make sure that it's not in the way of the actual view. So setting up your microscope, and you might have to do this not just the first day of work, but throughout. Microscopes get messed with. Cleaning happens around the microscope. They get bumped. They get changed. So maybe someone comes in to look at a sample that you're looking at, and they adjust it a little bit. And then so you need to know how to adjust it on the regular. So the first suggestion here: make sure that you adjust the seat height so that your eyes are comfortably at the eyepieces. You don't want to be, straining your neck, stretching it forward or up to look through the eyepieces. You don't want to have to scrunch down. You don't want your back to be kind of bent over. You want to be able to, back straight, feet flat on the floor, keep your neck straight and look through. Now, if you're only looking through a microscope for a tiny little bit, it might not matter. But if you're looking through a microscope for 8 hours a day, 4 hours a day, it's going to matter. Your body will strain. The parts that are straining are going to start hurting after a while. If you're in a high chair, like if your desk is super high, it's preferable that your feet are flat on the floor. But some of these chairs have like rings around the bottom that you can put your feet flat on. If you're at a standing desk, your back straight, feet flat on the floor still, but you're just standing instead of sitting. Turn the light source on. So when you do this, there is an on and off switch, but then there is also a dial that can go from low to high. When it's off, you always want it to be in the low setting. So when you turn it on, the light bulb is low, and then you dial it to higher. When you turn it off, you're going to dial it back to low before turning it off. It's going to save the light bulb. Some of these light bulbs are expensive, and it's going to save them so you don't have to replace them more often. You're going to put your specimen under the scope. You're going to put it in a petri dish. It's best to put it in a petri dish so you can slide the petri dish around instead of having to move the specimen every little time you need to slightly see different spots. you will be manipulating that mosquito when you're, flipping it over, looking at the top, looking at the underside, things like that. But it's especially when you dump them out and you've got lots of mosquitoes on a petri dish, or you need to look at lots of mosquitoes at once. Having it in a petri dish and you can move around is very, very easy to do. You want to adjust the eyepieces so that you're not seeing double. So how we're going to do this, you're going to adjust the eyepiece stems, bringing the stems closer or farther apart. So, have the sample under the microscope. It's not going to be perfect at this moment, but you are going to adjust the eyepieces by bringing them in closer or farther, and so that you're only seeing one of your specimen. It might not be in focus yet because we haven't fixed that, but you want to be able to see just one and not have it be doubled like this. Then we're going to work on the focus. So some microscopes, both eyepieces can be adjusted and some of them only one. If both of them can be adjusted, then it doesn't matter which eye you close first. But if only one of the eyepieces can be adjusted, then you're going to close the eye where the piece can be adjusted, and then the one that's stable, you're going to have that eye open. And so close one eye, and you're going to adjust the focus so that a particular part of the mosquito is in really good focus. You'll zoom in on the body part and then you'll bring it into focus. Use the coarse and then fine adjustment knobs to bring it into focus. And you can see in the pictures that I'm showing, when you're looking at through these microscopes, your depth of field is very small. Just like working with a camera, when you zoom in close to the mosquito, your depth of field is very small. And so just by slightly adjusting, you can see how different portions of the mosquito are in focus. And then on the picture on the bottom, just a slight adjustment, different parts of the mosquito are in focus. So once you have your eye closed and then that part is in perfect focus with the one eye, well, for here, I have, looking at this spiracle on the bottom is in perfect focus, and then at the top, it's not in perfect focus. So if you were to have your, let's say, one eye closed, so the one eye that's open is looking at the bottom, looking at that spiracle. And then when you switch your eyes, now you see that the eye that's open, it's out of focus. So then you're going to adjust the eyepiece so that it's in focus, so that both eyes are seeing the same thing in perfect focus. And so with the other eye open only, adjust the eyepiece focus. Some scopes, again, only have one, so you want to make sure that you're doing it, that first eye is going to be the one that is is not able to move. And then you'll spin it, making sure that the same body part is in perfect focus for both eyes. And then you're ready to set, you're ready to ID. When finished IDing specimens, you're going to turn your light to the low position. Usually we give it a couple, 30 seconds or so to kind of cool off, and then to cool off a little bit, and then we'll turn it off. But if you have to turn it off immediately, definitely put it in the low position first. And you probably want to cover your microscope when you're done for the day to keep it clean, so that it'll last longer. Microscopes are not cheap. When manipulating specimens, you'll be using forceps. Forceps are going to be very foreign to you at first. Manipulating these mosquitoes is not going to feel natural. But after a while, it's going to It's going to be like an extension of your hand. It's going to be very, very fluid. And so when using these forceps, you want to be gentle with them. You don't want to squeeze super hard because then you're just going to snap off whatever part of the mosquito you're holding. So light pressure. You'll avoid the very tip of the forceps, kind of a little farther back on the forceps. The older the specimens are, the more fragile they're going to be. If you're going to be IDing specimens currently while going through this ID course, most likely the specimens you're going to be looking at, most of them are going to be at least a season old because they were collected throughout last season. And so legs will snap. Antennae proboscis is going to snap off. It is what it is. But you're learning on these specimens, and then hopefully, that'll only make you better as time goes on. When you're picking up the mosquito, you want to pick them up by the legs. So usually if you're picking them up by the legs, you want to avoid the hind leg because the hind leg a lot of the times has those characteristics that you're going to be looking for. So go for the front leg or the mid leg. Going for the wings, maybe going for a certain portion of the wing, the tip of the wing, so that you're not damaging it. The proboscis, all of these, if you have to manipulate the mosquito in certain ways, you can use all of these different body parts just to be able to move it around correctly. You want to avoid picking it up by the abdomen, the thorax, or the head. So these big, thick portions of the mosquito. Because when you're picking them up, you're likely to squeeze those soft body parts, and then that is really going to disfigure your specimen. Keeping pressure on the forceps, you'll twist your wrist to view as needed. So when you're choosing what body part to pick it up by, you're going to think about how you're going to be able to twist your wrist in order to see the top of the thorax, the underside of the abdomen, or whatever portion of the body you're trying to look at. So now we're ready to look at a specimen under the microscope and go through a dichotomous key to try to figure out what it is. Talk to your biologists or whoever's in charge. They should be able to give you the exact specimen, the same species that I am working with here. And it would be very helpful to be able to see it with your own eyes and kind of pause this video and look at the portion that we're talking about, making sure that you know what I'm seeing and what I'm talking about. If you happen to know, as soon as a specimen's under your microscope, you know exactly what it is, I don't need to use the dichotomous key. I know what this is. That's great. And as time goes on, you're going to learn these specimens. All of these key characteristics that we talked about before when talking about the different genera and the species within those genera, they all kind of have key characteristics that if you've been doing this for a while, you know exactly what they are really quickly. Well, at first, you guys don't know these key characteristics. So being able to use a dichotomous key is a needed, useful tool. Every once in a while, everybody pulls out their key. I've got a specimen. I just don't know what this is. I'm going to go through the dichotomous key and try to figure this out. And so being able to have that tool and know how to use it is, pun intended, key to IDing. And so if you don't have a biologist and you're basically kind of, you're doing all of this on your own, a dichotomous key is definitely super, super helpful. So if you've never used a dichotomous key, it's kind of like a choose your own adventure. These are old books from when I was a kid. Maybe some of you don't really know what Choose Your Own Adventure books are, but there's now some newer Choose Your Own Adventure movies, and it's the same kind of concept. You read on through the book, and then you get to a spot that's it gives you It gives you some sort of situation, and then you choose which direction to go. So you stumble onto a dragon as you're hiking through a cave. Turn to page 65 if you want to run away. Turn to page 75 if you want to stand your ground and fight. And so then you're going to go to whatever page you want your next step to be. Well, with mosquitoes and a dichotomous key, instead of you just choosing which one you want to go to, you're going to look at the morphological characteristics that are in front of you, and that will determine which page or which couplet you're going to go to. There are lots of different dichotomous keys out there that you could use. Some are older, some are, we've got the Mid-Atlantic region, an older Mid-Atlantic region dichotomous key to the left. We have all of North America on the right. And so the North American one, the Darcian ward, is filled with mosquito species. And so that might be overkill. You don't need to go through all of those to figure out what's in Virginia, what's in your particular area, because you're looking, it might be hard to figure that out when you're looking at what's all over North America. So regional is much better, but if you do find something that's unusual that has been transplanted from somewhere else, you might not find it in your regional one. You might have to go to a larger, more expansive key to be able to figure it out. So having multiple of these keys at hand is definitely beneficial. This is one that's been used for a long time. This is a Slaffen-Apperson key to the Mid-Atlantic states. I actually have an example of this one where Bruce Harrison had made some updates to it. That's the one I used in the beginning of my career and used for a lot of years. And then over to the right is a list of all the species that are in there. This is the key that I currently use. If we were having an in-person mosquito course, ID course, this is the one that we would be using in our ID course. It is a Bruce Harrison, Brian Bird, Parker Witt, and Charles Sither are the authors of this key. It came out maybe 5 years ago, something like that. I really like it. It's a great key, Mid-Atlantic region area. There are some great pictures showing you the mosquito anatomy. So not only is it adult, but it also has larvae. I would focus on adult at first. Once you get good at it, then you can jump into larvae. Both are extremely fun. And so here's some key characteristics. If you ever, it's steering you into a particular portion of the mosquito. If you don't remember what that is, you can go through these pages. So I think that last page was actually from the older key. These are the newer, this is the newer key, and it has much more parts of the body. You can see on the right, or you can see on the left, all the general portions of the mosquito, even looking at the veins in the wing. And then on the right, you've got the parts of the head, the parts of the abdomen, the parts of the wing zoomed in. All of those plates on the side of the thorax and the top of the thorax, all of these things that have been talking about and will be using in the key. So here's your specimen. If you know it already, that's great. But we're going to still go through this exercise and learn how to use the key. Now, if we were in person and we were going through this key, you'll stumble across some couplets, some portions that are saying, does it have this particular characteristic? Does it not have this characteristic? And if you were to ask the biologists as they were walking around, some of us would be super stumped. Like, I never look for that characteristic. Like, it's just something, as soon as I see this picture, I'm like, oh yeah, I know what that is. So when you're, not ever using some of these characteristics, sometimes it's a biologist that uses the key all the time. We still have to kind of think about, wait, what is that characteristic? Okay, and it has to be, this size, or it has to be, okay. So it might take us a little bit, but, we know how to use the key, and we should be able to steer you in the right direction. So here we are at our first couplet. This can be found on page 28 of your ID book, the Mosquitoes of the Mid-Atlantic Region and Identification Guide. This is going to be page 28 after the pictures of the general kind of parts of adult mosquitoes. So in this couplet, this is going to be couplet 1. And so if our specimen meets the criteria of this top portion, then it's sending us to couplet 2 next. If it meets the criteria of this bottom portion, then it's going to send us to the couplet 3. Now sometimes the couplets that it's going to be sending you to are not, very close. I mean, here we've got 2 and 3 after 1. Sometimes you could be skipping a whole bunch down the line, and that's just because there are a lot of groupings, either genera or species, and so that characteristic has split off several of them to then you need to split off. And so you just follow the couplet and go to where it's going to lead you next. You never go backwards. So you're not going to go, couplet 1 to couplet 5 to couplet 8, and then all of a sudden back to 3. You would keep progressing. You never will come back. So let's look at some of these characteristics. So the very first characteristic is usually the most important characteristic in this differentiation. Sometimes there's only one characteristic. Sometimes there's multiple. And a lot of the times the second and third and fourth characteristics, they tend to be a little bit more detailed. And I'm not going to say is important because they're important, but they could be harder to kind of tell. And you don't always have to go through every single one of them to make sure. So with this here, the very first one, the palpus, which is also the palpi, the palpus is longer than the antennae. And so that's figure 1, and that is a picture. Figure 1 here shows that happening. The palpi, the palpus, which is singular for palpi, is up here at the top, and then your proboscis is at the bottom. And then when you look at the bottom portion here, the palpus is much shorter than the antennae. And that goes to figure 3, and we see that this short palpus and then the proboscis at the bottom. And so we can look at our specimen and we can see that our palpi is shorter than the long proboscis here. And so that right there, we know, I would feel confident we could move on going to couplet 3. But if we weren't quite sure, maybe it looked like the palpi was kind of ripped off or was damaged, or maybe the proboscis, something was wrong and we weren't quite sure. Well, then the next characteristic is talking about the scutellum, which is this plate that comes off the back end of the thorax. And so in this case, it is rounded, and there is evenly dispersed setae on this scutellum. Whereas here we have the 3-lobed scutellum, and then the setae are confined to each lobe. I don't have a picture of this last characteristic, but if you're looking at your specimen now, you can kind of pull back the wings and you can check it out for yourself, making sure that, yes, the palpi matches this. Does the scutellum match that? Here I am showing some examples of long palpi versus short palpi. I mean, our specimen has the short palpi, but just to make sure that you know some of these differences, because a lot of the times if you see something in the key, it's very hard to imagine what it would look like without seeing an exact example of it. And so here's a drawing of the long palpi on the left side versus the short palpi on the right side. And then here is an example of long palpi, and this is the Anopheles, the genus Anopheles having the very long palpi. And then here is Aedes aegypti having very short palpi. And then I draw the box around to kind of give you an idea. And if we, if the palpi were as long as the proboscis, we would then jump to couplet 2, which we are not. But if we did, we would jump to couplet 2, and we would see these two genera here, which is Toxorynchides and Anopheles. You will be finding lots of Anopheles throughout your IDing career. Toxorynchides are a little more rare, and so if you're seeing, oh well, this has a long curved proboscis, maybe I have something like this. Well, the Toxorynchides, we don't see much of them, so I'm showing you this here. They are enormous mosquitoes, super large. They have these iridescent blue or purple colored scales on their thorax and legs and the palpi here, and they're just gigantic mosquitoes, very long curved proboscis. So our mosquito has palpi shorter than the proboscis, and so we are going to move on to couplet 3 to figure out what genus our specimen is. So when we look here, this top portion is going to couplet 4, or the bottom portion is telling us that we have Wyomia smithii. Well, I'll let you know right off the bat, Wyomia smithii is a rare species in our area. I've never seen one in person. And so that doesn't mean that you're never going to find one, but it does kind of, what are the chances kind of thing. But we'll do this either way. So the scutum and scutellum with seedy and small scales versus the scutum and scutellum covered in round flat scales. And we'll hopefully, I think I have a picture of what that looks like. Sorry, grabbing my mouse. And so that's looking at this first portion versus this portion. And then the next is the Meso-postnotum is going to be without seedy, where in the bottom, the Meso-postnotum is going to have a small patch of seedy. And so that's kind of this area here. So we're looking at the scutum, which is the thorax. This portion right here, this is the first segment of the abdomen. And then this connecting material that kind of bends, it looks kind of like a lobe that connects the two. There will not be, this is the Meso-postnotum. There is no seedy visible here, but then here there is seedy. So now let's look at our sample. Well, we're not going to look exactly at our sample first. I'm going to show you some examples of a Wyomia smithii first. And so you can see here we have this abdomen that is laterally divided, so that's like completely white on the bottom. On the ventral side, the dorsal is completely dark. And then I'll kind of zoom in on this Meso-postnotum area or this metathorax area. And so we're kind of looking at this region here on the diagram. we're looking here for the CD. So just to give you a better idea of what we're looking at and a better idea of what a Wyomia smithii looks like if you haven't already seen one. Now, the specimen that I had originally, this is a picture of that specimen that I flipped over, and we are looking at the Meso-postnotum right here, and there is no patch of CD coming off here. So that means we'll be moving on to the next couplet, which is couplet 4. Now, I skipped over, that beginning part of the CD on the thorax. I didn't have a good picture of the CD, the short rounded kind of CD that's on the Wyomia smithii. So I skipped over that just because I didn't have a good picture to show. But you can see the CD on the thorax here. There are very long CD coming off here, but there are shorter CD all throughout here, and it's not that thick kind of rounded looking CD. So we moved on to couplet 4. Couplet 4 is looking at the postspiracular CD, the postspiracular area, if there is CD present. So remember, this is the spiracle here, found in both pictures. And then the postspiracular area is the area behind. So this is the head over here. The abdomen is not drawn, but the abdomen would be here. This is looking at what it would look like with a patch of CD versus no CD. So now let's look at our specimen. Same species. I'm zooming in, and I have the spiracle here. It's not as open. Sometimes it's a little more closed. Sometimes it's a little more open. This one is kind of halfway open. And then this is the subspiracular area. I do not see CD. Whereas this is an example of here we have the spiracle. Here we have the subspiracular area. You might not be able to identify, but this is this shape right here, that kind of club shape. And right here is the subspiracular area, and there is white CD. So that means we know that our specimen does not have CD on the subspiracular CD. So then I believe that sends us to, I think that was 7. Oh, I draw the subspiracular area. Yes, it sends us to 7. So now we're looking at this couplet could be sending us to Uranitania, or it could be sending us to couplet 8. Now, if you know anything about Uranitania, you would know they are small mosquitoes. They have this kind of metallic rows of metallic blue scales on them, and it's hard to miss those kind of characteristics. Whereas the specimen on the lower portion, there are no metallic blue scales, and then the wing with tip of vein 1A reaching wing margin beyond this perpendicular line. So it's kind of, if you draw a line here perpendicular to the wing, is this area meeting, is this joint here meeting that perpendicular line? I'm sorry, I have my mouse. So this line right here, this vein, is it before this perpendicular line that separates it in half, or is it after? And so, looking at that characteristic is a little more difficult, a little bit more involved, but that first characteristic of the blue scales is not very involved. I mean, you can easily tell what's going on there, if it's present or if it's not present. So let's look at our sample. Or the next picture might be looking at a sample width. Yes. So if we had a sample with this blue metallic Setae, this is what you would see. You would not only see that it was a small mosquito, you would not only see that it has this broad, flat kind of proboscis at the end, but you would see these bright blue, bright purple, metallic Setae all throughout the mosquito. And our specimen does not have that. This is a Uranitania sapphirina. So that sends us to couplet 8. As we see here, couplet 8, the top portion, is going to send us to couplet 9, or the bottom is going to send us to the genus Culiseta. Some of these characteristics you might have to really zoom in on to see, but it is good to know how to find these characteristics. So here we have the base of the subcostal vein on the underside of the wing without a small patch of Setae. So basically we're seeing this on these pictures here. If you think of this wing as being your arm, if you were to open up your arm, and it's kind of the area that would be the shoulder above the armpit. And so is there going to be a patch of Setae there, or I'm sorry, is there not going to be a patch of Setae there, or will there be a patch of Setae there? And then the next segment is talking about Prespiracular Setae present, so right before this spiracle. Is there, or I should say, is there or is there not? So now we're going to look at our specimen. And so this is kind of an angle to look at to see this Setae in the armpit area. And so when you zoom in, I know it is very difficult to see, but when you kind of move it around, you might be able to see it even better. But this is the armpit area. Vein, I think, what did it say, 1A? Right here, the Setae coming off, and it's longer Setae than any of the other Setae that you're going to find on the wing around this area. And so that is present. There's another picture that's a professional picture taken showing that patch of Setae on the wing. And again, this is going to be the body over here, and it's kind of opening up the wing, so you're looking at the underside of the wing. Then we zoom into this prespiracular area, and this is the spiracle. And right before the prespiracular area here, we do see Setae. We see a patch of Setae right there. So your specimen is the genus Culiseta. I believe you can now go farther into the book to see the genus Culiseta, which is divided out into species, and you can look and see which species it is. I think there's only 2 in there, Inornata and Melanura, but I could be wrong. There could be a couple more. I know there's much more in the United States, but I can't think of another one that's in this area. So some of the older keys have had some characteristics that weren't talked about, but they are associated with this particular mosquito. And the first one to talk about here, and so this couplet that we're looking at is an older couplet. It's I believe the Slaffen Apperson with the notes of Dr. Harrison. And so it's talking about the abdomen, the tip of the abdomen being rounded or pointed. And this specimen, this Melanura, this Culiseta melanura, just gave away what species it is. It has a rounded abdomen. And so something to remember. And then this whole apical versus rounded. I have an apical, I'm sorry, the apical shape of the abdomen being pointed or rounded, and it's showing you the examples here. Another older, in that same Slap and Apperson key, they talk about the scales on the wings. And so, are they narrow or are they broad? And sometimes when you're thinking about this, if you've not seen broad to compare it to, then you might think that something is slightly broader and you're like, oh, that's definitely broader. But no, when you look at a Cochleatidia perturbans, you're going to see a much broader scale. And so you'll really know the differences between the broad and narrow. And here's pictures showing broad on the right and then narrow on the left. And then here, this idea of the tuft of Setae on the underside of the wing, but then we're also talking about the length of the proboscis. So Culiseta, the proboscis is usually greater than a third of the body length, or if it's Culex, it would be less than a third of the body length. And so when comparing these lengths of proboscis, you might not know. If you've not seen a long proboscis, you don't know how much longer it is, and it's kind of hard to tell. But here I have pictures showing a Culex and a Culiseta. The Culiseta here with its proboscis and the Culex here with its proboscis. When you zoom in next to each other, you can see that the Culiseta's proboscis is much longer than this Culex. Also, another characteristic that's not talked about is the hairy chest. So if you're trying to decipher between a Melanura and a Culex, and that length of the proboscis is just, you just can't figure it out, and you can't find that underarm, the armpit hair on the wing. The Melanura, Culex Melanura, has a much hairier chest here, lots more setae coming off than a Culex does, if that's a benefit to you. And then we're back to this this couplet that we find in the older key, and basically, is it a Culex? Is it a Culiseta? And it is a Culiseta, just like we found before. And so now you know what genus it is. You can now go figure out what species it is, if I didn't already spoil that for you, which I know I did. And then, go through some couplets, go through these keys, looking at some of the other specimens, and enjoy.